Hello, my name is Yongil and I am present our work preparing cross-modal attention via object detection. Several studies have been conducted on multimodal learning models that deal with various modalities having different characteristics such as image, text, and speech information. Vision and language, which includes visual QA and image captioning, is one of the most extensively studied fields that achieves the desired output by receiving image and text information as input. Most multimodal models that display the best performance use attention mechanisms to mix two or more modalities. Attention techniques help the model learn the most important parts on its own and share relevant details between the two modalities. Unlike attention applied in one modality, such as self-attention, cross-modal attention is applied between two modalities. In particular, cross-modal attention has become essential in multimodal models because transform models based on attention techniques exhibit strengths in multimodal learning tasks. Additionally, many studies have displayed excellent performances using cross-modal attention in vision and language research. However, most existing vision and language models only leverage the cross-modal attention module, and there have been no attempts to improve it. In other words, no study has directly trained the cross-modal attention module using an object function. In this paper, we propose a methodology that directly improves cross-modal attention in vision and language research, thus increasing the model's overall performance. Specifically, we propose a method to improve attention mechanisms using object detection models. Recently, powerful object detection models such as Jetron2 have emerged that show performances similar to or even exceeding those of humans. We leverage the ability of these object detection models to improve cross-modal attention through pseudo self-attention, self-supervised learning. As shown in this figure, the object mask obtained by passing the input image through the object detection model was used as a pseudo label, and an auxiliary loss was configured such that attention map output by the cross-modal attention model of the vision language model was similar to the pseudo label. This algorithm provides our novel training scheme for improving cross-modal attention. First, the object detection model extracts object instances from the input image and corresponding masks. Then among the labels of the object stack, we select the one that matches the word token in the input sequence. Additionally, the masks of the instance corresponding to these critical objects are merged. The merged mask is then used as a pseudo ground truth label for the attention map corresponding to the word token. Because of the bias in the detection model, it is called as a pseudo ground truth label, but as the performance of recent object detection model exceeds human capabilities, they can be considered as approaching human annotated ground truth labels. Finally, the surrogate IOU loss is measured with the attention map output by the attention model in the vision language model, and the pseudo attention label is used as an auxiliary loss. For the surrogate IOU loss, the robust hinge extension of Jacquard loss is used. This figure shows the proposed methodology applied to the image captioning task. When the word token of the text sequence matches the detected object label, the masks of the object instances are merged. After that, an auxiliary loss is constructed between the merged mask and the attention map of the word token using the surrogate IOU. We conducted an experiment using image captioning in a vision language task. The show and tell model was used as a baseline. This baseline model utilized the attention model and attention with an image corresponding to each word token of the caption. The experimental results are listed in table 1. The ICA loss improves the cross-modal attention loss, which is the auxiliary loss added in this study. The model to which the proposed auxiliary loss is added shows much better performance across all datasets and performance indicators. The proposed methodology can be applied to all vision language studies other than image captioning. Thank you.